How would the like the sunset and sunrise over the horizon, how does that work in a flat Earth model? If if the sun, like if this is the if this is the flat Earth and then the sun's going around this way, wouldn't we just see it as just kind of fading out? Or how does the horizons work with that?
Yeah, perfect. Also, day and night. The question you just asked usually goes hand in hand with, how come it's a day on one side and night on the other, or in time zones? How does that work?
Right.
So I made this animation to explain that based on the research that I was doing. I'm not the originator of this idea. I just created, I wanted to do it for myself. So you got the flat Earth model, and now using a sextant, which I've never used and don't know how to use, but I've been reading about people who have used the sextant to calculate the distance of the sun. And from what I understand, it comes out to the sun being almost about a 40-mile diameter at I think 3,000 miles away in that model. So this is not to scale. Actually, if it was to scale, the sun would be smaller. But just to illustrate that, in the flat earther model, at least as I understand it, the sun's about 40 feet across and about 3,000 miles above the Earth. Well, this is how it goes around and creates time zones and all of that, day and night and time zones. Now, this is kind of falling right above the equatorial path right here. This kind of line right here is the equator. How do you explain the seasons, and how do you explain seasons or times of the year when the sun is visible all day long, like in the Arctic, or not at all? And the case with the Antarctic and Arctic, where either the sun is there like constantly or not there at all. Well, according to the flat earther model and according to the Book of Enoch, all the sun does is it tightens its circle a little bit to be a little more in for certain seasons. This time of the year, it's more going around the equator, I guess, and other times of the year it's further out. So it's following a path, and Enoch tells you it's got a path that it has to follow for specific times and gates and whatnot, that apparently whatever it goes through for the seasons and whatnot. So there's that. Now, you've got you're looking at a simple little illustration right here. In the real world, this thing is huge. This disc, I mean, if this is the truth, this disc is massively huge. Now, I know from being in aviation, and watching aircraft come up over hills, that, okay, let's say I'm looking at a hilltop in the distance, and let me undo this here. Okay, say I'm over here. I'm over here, and there's like a mountain range or a hill or whatever over here, and there's a helicopter flying at, let's say, 1,500 feet. Over here, my field of view can't see over this mountain, to the level of where the helicopter is way over here. But as it's coming, I mean, it has this kind of illusion like it's coming up over the mountain, and then going up over my head and then disappearing the same way as the vantage point, as it decreases, it looks like it's going down. You see what I mean?
Yeah.
So I was thinking about it the other day. I was trying to catch the sunrise, which is rare because I'm never up. I stayed up late enough to see the sun. I didn't get up to see it. And I was looking, I'm like, okay, from my vantage point in Plano, Texas, I mean, because of buildings and trees and, other obstructions, I can only see so far. And even if I'm standing on a mountain looking, my visual ability to see is only so far. And yet, if the sun is beyond that ability to where I can see, because my vantage point is come to an end, it's beyond that, it would have the illusion of coming up toward me. Does that make sense?
Yeah.
So if you're looking like this, and it's sort of doing that, it has the illusion. You got to think on a huge scale. I mean, just if we just think on the size of the United States of America, and a bus 40 feet wide, was flying in the sky, you're not going to see it from Massachusetts if you're in California. You know what I'm saying? But as that 40-foot bus starts flying over from Nevada, it might start to become a little bit visible at 40 miles across. You know what I mean? So
yeah, that makes.
I'm not sure that solves the problem, but just when thinking about visual perspective and our ability to perceive at a distance, I can see how that could have the illusion of coming up and going down. But here's the other thing that's tripping me up is there are times, I mean, looking at that model of the sun going around the flat plane, I've looked up and seen the sun directly over my head. And we usually say, well, it's 12 noon. Well, I mean, if the sun's 40 miles across, 3,000 miles up, and it's over the equator, and I'm in the northern hemisphere, North America, how does it look like it's right over me? It seems like I should always be looking at it like, at an angle. You know what I mean?
Right.
But you have the exact same problem. In fact, it's actually worse on a globe. Because if this is the sun and you're up here on the globe, how do you make the sun look like it's right? I mean, the Earth's not rotating this way. You know what I mean? It's rotating.
Right. Yeah.
It's rotating this way. So, I mean, these are like the mind-bending things that you sit there, you're going, my gerbil's running as fast as it can, because all the stuff, the same questions people are asking about, well, how's that work on a flat Earth? A lot of them you got to ask, how's it working on a globe?
Right.
I mean, if the Earth is supposedly at, and this is interesting, 23.4 degrees, 23.4 degrees off of a 90-degree angle is 66.6 degrees. 66.6. Like, really? Seriously? Come on. Why? I mean, come on. I mean, for years I said 23.5 degrees. And then when I started doing the search on it, I'm finding, nope, actually, the scientists say it's 23.4. And I'm going,
wow.
23.4, 66.6 off 66.6 off center. Put it that way. So if you've got a sun that's 93 million miles away, way over here, off center of the equator, and you're up here in North America, I still don't see how you're getting the sun to look right over the top of your head, because the Earth's not rotating this way. It's rotating this way.
Right. Yeah, that's a good point.